Good day, learners. Welcome to Technical Sciences lesson. My name is Zamisile Mdima. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Today, we're going to be looking at Redox reaction as per our annual teaching plan. So let's get started. So in us getting started, we're going to be looking at the pillars that we're going to touch based on, which are going to be mainly our subtopics that we're going to be looking at. So first up, we're going to be looking at oxidation, reduction as well. We're going to look at the different anode, cathode, reducing agents, oxidizing agents. We're going to also look at the process of electrolysis, which is electrolysis of salt solution to be specific, okay? And lastly, we're going to be looking at electroplating, its benefits, why is it done, and why is it beneficial to us humans, okay? So moving right along, but before we even get started on the main lesson itself, let's look at the lesson objective. What is it that I want you and I to be comfortable with at the end of this lesson? First up, I want us to be comfortable in being able to define the terms of oxidation and reduction, being able to identify oxidation reaction as well as reduction reaction, okay, which happens simultaneously. Number two, I want you and I to be able to determine the oxidation numbers of different molecules in a compound or in a chemical equation, whichever that you are given at that particular time, be able to determine the oxidation numbers either of a molecule or a chemical equation. And lastly, I want us to be able to determine and identify reducing agents as well as oxidizing agents in a chemical equation as well. So this is our lesson objective for today's lesson, okay? But before we even get into the main lesson for today, let's take a step back and look at the knowledge that we gained in grade 10. What is it that we spoke about in relation to what we're going to be talking about today? So in grade 10, we spoke about pure substances. We said that pure substances exist as elements, and they can exist as what? As compounds, all right? And then we went further to define what is an element, what is a compound, so that we are able to identify them as and when we come across them. We defined an element as a substance that cannot be broken down into simply a substance by chemical means, all right? And then we defined a compound as a substance that consists of two or more elements that are chemically bonded to each other at a specific ratio, okay? So giving an example of an element will be your oxygen, and then oxygen, because this is a diatomic molecule, it is existing in twos, and then will be your hydrogen, it will be your chlorine. All of these are elements, okay? Because they are existing as what? As a diatomic molecules, okay? Other ones that do not exist as diatomic molecule, meaning that they do not have to go in two atoms, okay? We can just say it's sulfur, we can say it's oxygen, okay? Remember, oxygen, we've counted it as a diatomic molecule. We can say it is phosphorus, and all of those that are present in the what? In the periodic table of elements. And then when we come to compounds, we talk in terms of NaCl, okay, and we say that it is a compound because it is made up of two elements that are chemically bonded to each other at a specific ratio. It could be your copper chloride. This is also what is regarded as a compound because now we're consisting of two elements now, which is your copper as well as your what? Your chlorine. All right. Moving right along, it's a quick recap from our grade 10 work. We also said that the formation of cations and anions, okay? Now, we had to understand how then do we form the cations and how do we form the anions, okay? So it has to do with the loss, or rather the gain, of electrons. Okay, this is a process that happens simultaneously. As soon as one element loses electrons, the other element can gain the electrons. All right, so that's how then we are able to form what we call cations and what we form anions. Okay, which is just like the basis of today's lesson. Okay, the loss of electrons, okay, as well as the gain of electrons. So we're just merely looking at the movement of electrons. All right, so then you ask yourself, what did we say cations were? Let me refresh your memory again. We said cations are positively charged ions, okay? And also we said that anions are negatively charged ions, all right? So this takes us back in us understanding what is referred to when we say that a molecule or a compound is neutral, okay, and what we refer to when now it is positively charged and what we refer to when it is negatively charged. All of these things has to do with the electrons and protons with regarding to the compound being neutral. It has to do with having the equal number of electrons and the equal number of what? Of protons. Now, once the compound that has been neutral then loses the electrons, immediately that compound then becomes positively charged, okay? And where those electrons are being gained, that compound is then going to be what? Negatively charged, because it has more electrons as compared to the protons. All right. So this is just a quick recap on grade 10 work that which is the basic knowledge that we're going to need for today's lesson. All right. So also we spoke now about the periodic table itself. Okay, trying to analyze where the metals are at, where the non-metals are at, where the semi-metals are at. All right, so we said that the charge of simple ions can generally be deducted from the group number in your periodic table. So at the top, I've got the group number, which is group number 1, number 2, number 13, number 14, 15, 16, 17, as well as 18. Okay, so depending on where the element is placed in the periodic table, we are able to tell the oxidation number, or rather the charge in it. All right, so the charge on elements in group number 1 is +1, and then the charge on the elements in group number 2 is +2, and then on group 13 is going to be +3, and then group 14 is going to be positive or -4. And then 15, 16, 17, we've got -3, -2, -1, and 0. And we regard 0 to be what? To be that neutral charge, okay? Because it's neither a cation or an anion, okay? So remember we said the positive charge is the ions that have the positive charge will be the ones that we refer to as cations, and then the ones that have the negative charge are the ones that we call anions. Okay, so they're both ions, just different types of ions, having a positive charge or the negative charge. Okay, and this positive charge comes from this movement of what? Of electrons. As soon as now we lose the element loses electrons, it automatically becomes now positive, okay, positively charged, okay, and the one that gains these electrons becomes negatively charged, because now it has more of what is negatively charged, and in this case it is electrons. All right, so we're also in that periodic table in grade 10, we rather be able to say, okay, where are our metals, where are our metalloids, and then where are our non-metals. We went as far as giving them characteristics. Then how can we see that this one is a metal? So they are shiny, they're good conductors of electricity and heat, whereas the non-metals are everything that the metals are. So if the metals are shiny and good looking, then the non-metals are dull. Okay, they're not good conductors. They are mostly insulators, okay, and they are not good conductors of heat and electricity. Okay, so it's just quite the opposite of the two. And then metalloids, they are in between, depending on how they are treated. They are not that good conductors of electricity. They're not also that bad. That is why you find them in the middle of our periodic table. All right, so just to browse in and remind ourselves, refresh our memories on what metals are. We said metals are good conductors that have between 1 and 3 electrons in the outer level. And those electrons that are in the outer level are the ones that we call valence electrons, and they are very loosely bound, meaning that they are able to move around very easily from one element into another. Okay. Also, we did go in detail to define what a nonmetal is and how can we see a nonmetal. We said nonmetals are poor conductors of heat and electricity. They contain about 4 to 7, well, and 7 valence electrons. Okay, these electrons are firmly bound. Okay, meaning that they're unable to move around very easily. Okay, so that is why you'll find that your nonmetals, because they don't have those valence electrons that are loosely bound. The electrons that are found there are firmly bound, so they mostly do the accepting of the electrons. So you'll find that metals are the ones that lose electrons, and then the nonmetals are the ones that gain the electrons. Okay, so you can't just have one process happening without the other. So as soon as the electrons are being lost, there is a loss of electrons somewhere. So that means that all of those electrons are going to be gained somewhere else. Okay. Now, here's our periodic table, and let's just look at what we've been saying. So this is our group 1. All right, so that means that the charge in here for these elements is +1. It's going to be what? +2. And then we went to group 13, which is +3. And then group 14, which we said that it can be positive or -4. And then for this one, then it is -3, -2. Okay, and then -1 and then 0. So these are the charges that mostly happens. Obviously, there can be exceptions to some of the elements, but then in most of these elements, so this is what happens to them. So the ones that have a positive charge, those are the ones that we refer to as metals. All right, so the ones that have a negative charge, those are the ones that we refer to as what? As nonmetals. The metals do the giving. Okay, so with the metals, there's a loss. Okay, and then with the nonmetals, there's a gain. But we're going to look in details when it comes to that. Okay, so typically, this is what you see when we refer to the periodic table. It shows us the elements in their purest way. Okay, so this is your hydrogen, having all the details about hydrogen, your beryllium, all of them, and then how they are being placed in the periodic table tells us something about their electronegativity, about all their properties that they have. So this is why they are always grouped in the manner in which they are grouped in. Okay, so I know that we did cover this in grade 10, but just a quick recap so that as we move forward, you are able to move in together. All right, so today, specifically, this is what we want to do. We want to be able to identify oxidation numbers as per our lesson objectives. Now, we need to be able to then first define what is an oxidation number. Okay, what of significance does it have? So oxidation number shows us the number of electrons that an atom either gains or loses in a reaction. Okay, because now we said that in a reaction, this reaction happens simultaneously, meaning that at the same time. So when there is a loss or rather a gain, that means that there has to be a loss or a gain somewhere else. So if the electrons are lost, then they have to be gained somewhere. So that is why we refer them to as redox reaction. Okay, redox reaction, meaning that these happen simultaneously. This is for reduction, and this is for oxidation. Okay, we'll get into details as to what is oxidation, what is reduction, all right? Oxidation is the loss of electrons, okay? And then reduction, on the other side, it is the gain of electrons, okay? So as they're being lost, they're being gained somewhere else, okay? Oxidation number, then it shows us, okay, then the atoms that are being either gained or being lost in this reaction, Okay, like any other thing, it's got its own rules. Okay, we've got 10 rules that will run as one by one so that we are able to best explain the rule, so that two, we are able to implement the rule as and when it is needed. All right, so rule number one of being able to identify an oxidation number, whether to show whether this atom had gained electrons or this atom had lost electrons. How can we tell? Well, how can we see that this is an oxidation number? Okay, so first up, a molecule consisting of only one element always has an oxidation number of 0, since it is neutral. So what do we mean when we say it is a molecule consisting of only one element? We talk in terms of hydrogen. We did say hydrogen is a diatomic molecule. Okay, that is why it is H2. That means that because there is only one element, there's just two hydrogens here, two atoms of hydrogen. Okay, so it's just one element that is being repeated. So we have an oxidation number of what? Of 0. All right. So another example will be your bromine. Another one will be your chlorine, your iodine. Also has what? The oxidation number of 0. That is rule number one. So a molecule consisting of one element has an oxidation number of what? Of 0. Okay. Rule number two. Now, monatomic ions. And what do we mean by monatomic ions? We mean ions with only one element or the type of atom. Remember here we were talking about a molecule, all right? So now we're talking about ions. We did a quick recap on ions to say we've got cations, the ones that are positively charged. We also have anions, the ions that are negatively charged, right? So now, when we talk in terms of monatomic ion, we mean that ions with only one element or a type of what? Of an atom. So we say that they have an oxidation number which is equal to the charge. That is very important to note. So we say they have an oxidation number that is equals to the charge of the ion. What do we mean by that? Let's look at an example. So let's look at chlorine. Chlorine, we'll have a Cl minus. Cl minus. That means, what is the charge of, already we know that this is an ion because there is a negative sign at the top, all right? So let me write it here, Cl minus. So it has a negative charge at the top, okay? It is an ion, and in this case, it is a monatomic ion because it does have one element, okay? Mono means one. Maybe let me underline that part, means one. All right, so it's got just one type of element, okay? And then it is equals to the number, okay? Its oxidation number is equals to the charge. So the charge in here is just negative. So that is why its oxidation number is going to be what? To be -1. All right, so let's look at another one. We've got magnesium ion. Okay, it is a cation in this case. So because now we're saying the oxidation number, okay, of a monatomic ion, it's going to be equals to the charge, its own charge. In this case, we have magnesium ion having 2+ at the top, having a charge of 2+. That means it has an oxidation number of what? Of +2. Why is that? Because oxidation number is equal to the what? The charge in where? In a monatomic ion. All right. Moving right along, rule number 3. In a molecule or a compound, the sum of the oxidation numbers for each element in the molecule or compound will be 0. Let's break it down. So let's give it an example. The sum of oxidation number for the elements, for example, this compound in here is going to be what? It's going to be 0. Why? It's because there is no charge. It's not a cation. It's not an anion. It's just neutral. Why? Because it has no charge at the top. So its oxidation number is going to be what? It's going to be 0. Okay, because it's not positively charged or negatively charged. It is just a neutral molecule or a compound. Okay, so that is why we're saying the sum of oxidation numbers in each element or a molecule will be what? Will be 0. Rule number 4, in a molecule, the element that has the most electronegative is assigned the negative oxidation number. So that is why in your carbon dioxide, we know that the charge for your carbon will be positive 4 because of where it is located in the periodic table, and for oxygen is what? It is negative 2. So the most electronegative is what? Is oxygen. That is why it will take what? The negative oxidation number. Okay. Rule number 5, in a polyatomic ion. Poly means many. So we've got many atoms, okay, in this ion, all right? So in a polyatomic ion, the sum of the oxidation numbers is equals to the charge. It speaks to the same as what we spoke about in a monatomic ion. Let's give it an example. Okay, so let's give an example of a polyatomic ion. So we've got SO4 2 minus, all right? So the charge for this polyatomic ion is negative 2. So that means the oxidation number for this polyatomic ion is going to be what? To be negative 2. So it's take the charge of that polyatomic ion, all right? Number 6, so there's 10 rules. Number 6, rule number 6, an oxygen atom usually has an oxidation number of negative 2, okay? And then one exception is it when we're talking in terms of peroxides, okay, where oxygen now has an oxidation number of what? Of negative 1, okay? And for example, let's look at oxygen in water will have an oxidation of what? Of -2, while in hydrogen peroxide, it will have an oxidation number of what? Of -1. So that's the only exception when we're looking in terms of the hydrogen peroxide. But under normal circumstances, your oxygen atom will have an oxidation number of what? Of -2, okay, because of where it is situated in our periodic table of elements, all right? So in rule number 7, oxidation number of hydrogen is often +1, okay? Also, due to the fact that it is on what? On group number 1. Its position on the periodic table of elements. However, there could be exceptions where when we talk about metal halides, where the oxidation number can differ from +1 to what? To -1, okay? And then we give an example there of what? Of lithium, okay? When a hydrogen atom is in water, it is +1. However, if the oxidation number of hydrogen is in lithium hydride, then it is -1, okay? Then the oxidation number of halogens is -1. We know that. We've just dealt with the periodic table, and we did say that the oxidation number of halogens, okay, it is what? -1. And then elements in group 1 of the periodic table always have an oxidation number of +1, okay? Remember the exception just when we're talking about when the hydrogen is a hydride, for example, in a lithium hydride, all right? And then the last rule will be elements in group 2 of the periodic table have an oxidation number of what? Of +2. And we did speak about that. Remember, we spoke about 8 groups that we mostly focus on. So it's group number 1, group number 2, group 13, 14, 15, 16, 17, and then 18. With group number 1, it's a +1, it's a +2, right? Group 13, it's a +3. Group 14, it can be a positive or a -4. And then we look at what? This group, which can be what? -3, -2, and then -1. And then the other one is neutral, which is our group 18. All right. So because it has an oxidation number of 0. Okay. So all of them aspire to be group 18. They all aspire to be what? To be very stable, to be very neutral, okay? Right, now, redox reaction involves the electron transfer, We spoke about that one. As the electrons are being lost, here on the metals, they are being gained by the non-metals, okay? So these reactions happen concurrently. Hence, we had to break down what is the meaning of this redox. We said this is the reduction, and then this is what? The oxidation. Going further, what is reduction? Very important. The gain of electrons. What is oxidation? The loss of electrons. Okay, so that is the basic of this reaction, gain of electrons. Okay, let's dive deeper again, slowly this time. We're also saying in this lesson, redox reaction always involve the change in oxidation number. So oxidation number change as in when the oxidation happens and when the reduction is happening. So that is how we are able to identify, oh, due to the change in this oxidation number, there was oxidation. Due to this change of the oxidation number, there was reduction. So we're going to dive deep in how can we tell that, okay, even though there's a change in the oxidation number, whether there's a change in terms of a decrease or rather an increase in the oxidation number, what does that tell us? And how can we see that increase or decrease in the oxidation number? Okay, so oxidation and reduction, half reaction occur simultaneously, meaning that at the same time, we covered that part. So we've got mnemonics, okay, that will assist us in remembering all these terms and how they happen. All right, so let's start. We've got the first one, the first mnemonic, that is Leo Rayo. What does that stand for? And this is just an easier way for us to remember, okay, that loss of electrons is oxidation. It just gives us a definition, okay? So as you know this mnemonic, then they will be able to define, also to know which agent is which, okay? Now let's go slowly on it. So Leo Rayo stands for the loss of electrons, which is oxidation. So L is for loss of what? Of electrons, that is for E, is what? Is oxidation. Okay, that's the first part is covered. So we're always going to remember the Leo part, all right? And then reducing agent is oxidized, okay? So that means that the Rayo part of it, reducing agent, because we have to be able to see which one is a reducing agent, which one is what is an oxidizing agent. So reducing agent is what is oxidized. All right. That being said, oxidation number in this case, where oxidation happens, where the loss of electrons happens. So how can we see that oxidation has taken place in here? So we see by looking at the oxidation number will do what? Will increase. How so? You ask yourself. Let's look at lithium. Lithium, before it lost an electron, it had what? It was a whole, it was neutral, it was everything good, meaning that the number of protons and the electrons in it were equal, they were balanced, all right? So it had an oxidation number of what? Of 0. Why? Because it has just one element. Remember in the rules that we read, we said that if in a molecule it just have one, okay, one atom of it, then it's going to be what? It's a charge, or rather oxidation number is going to be what? It's going to be 0. However, then lithium lost an electron. In it losing an electron, then it became positively charged, okay? In its becoming positively charged, it has lost this electron over here due to it losing this electron, this one electron, all right? So now it's no longer, its oxidation number shifted from being a 0 to being what? Because now there is a charge in here. Now it's regarded as an ion. What type of ion is it? It is a cation. Okay, so what did we say about monatomic ions? We said that in monatomic ions, then the oxidation number is going to be its own charge. So it's equals to its charge. So in this case, we have one positive, okay, at the top. The charge is just positive. So it's going to be what? It has shifted from 0 to what? To positive 1. So when you're looking at it now and say, what happened? You look at the before and then you look at the what? At the after. What happened to the oxidation number of lithium? So before it was 0 and then now it is positive 1. So if you were to look at it in a Cartesian plane, 0 will be here where the lines are crossing, all right? And then as you go up, there is a positive 1, positive 2, positive 3, and so on. So the numbers keep increasing as you go up. And then as you go down, you're going to have -1, -2, -3. Okay, so the numbers are decreasing as you go down. Okay, so what happened is lithium was here. Its oxidation number was 0, but now it has shifted to being here. That means that the oxidation number increased. Then because there was an increase in the oxidation number, so this means that what has happened here is the loss of electron. What is the loss of electron, you ask yourself? Loss of electrons is oxidation, okay? So that is why Leori is very important. Even the way the equation is being written, it has to speak to us. So lithium was a whole, it was neutral. And then because it lost an electron, it became Li plus. Then plus the lost electron. Okay, hope it is clear enough. And then the reducing agent, the reducing agent is a substance that undergoes oxidation. This is very important. A reducing agent is a substance that undergoes oxidation. All right. And then we move on to the second mnemonics, which is G-raw. I always say G-raw because this is the raw part, and then there's a G-raw. And then what does it mean? What is it that it has to remind you of? All right. So G for gaining of electrons, okay, is what? Is reduction. Then oxidizing agent is then what? Reduced. How can we see that reduction has taken place? Which is what? Which is the gain of electrons. How can we tell? Okay, we can tell by looking at the oxidation number that it will do what? It will decrease. Okay, let's see how the oxidation number had decreased. So in this case, we said another rule that we spoke about. We said that the element, okay, that has the same type of atoms. We even said it's hydrogen, your bromine, your hydrogen, because these exist as diatomic molecules. Okay, so they will have an oxidation number which is equals to what? To 0. Okay, so here in this case we still do have another diatomic molecule which is chlorine. Before and the after. Before and the after the reaction. So here it has an oxidation number of what? Of 0. If we were to go back a little bit, this was just basically rule number 1. This one here. A molecule consisting of only one element has an oxidation number of what? Of 0. Okay? And then afterwards, it is an ion. Something has happened there. Has it gained or has it lost electrons? Okay, let's look at its charge because now it is regarded as what? An anion. All right, so what charge is there here? There is a negative because that is why we said it is an anion, it is negatively charged, right? So the charge of what? Of negative 1. So there was there was a decrease in the oxidation number. Looking back at our Cartesian plane, I like it to go back so that you can see the decrease from being a 0 to what? To being a -1. All right. So there was a decrease in what? In the oxidation number. So that is how we can tell that this chlorine ion has then went through what? The gain of electron, which is we can see by the decrease of oxidation number. All right. So chlorine was like this, and then it gained 2 electrons over here, and then it became 2Cl minus. Okay. Oxidizing agent is a substance that undergoes reduction. It is always vice versa. Reducing agent is a substance that undergoes oxidation. Oxidizing agent is a substance that undergoes what? Reduction. So then we have 2 electrodes that are very important. These electrodes are where these 2 reactions take place. Yes, we've covered they happen simultaneously, but where do they take place? In which electrode? Okay, which one is an anode? Which one is a cathode? And how can we tell that this one is an anode and this one is a cathode? So an anode all the time, it is an electrode where oxidation takes place. That's why we even have an abbreviation of what? An ox. We do have an animal called an ox. Okay, so it's the electrode where oxidation takes place. And then we've got a cathode. What is a cathode? An electrode, okay, because they are solid, where reduction takes place. And then it takes us back to what we're talking about. What is oxidation? What is reduction? Okay? And then it goes back to the what? The oxidation numbers that we're just merely talking about in this lesson. Okay, so you have to see if you're talking in terms of what the loss of electrons, you have to see the increase in the oxidation number. When you're talking in terms of the gaining of electrons, which is reduction, you have to see the decrease of the oxidation number. Okay, specifically on this part, we're trying to establish where these reactions, we know they happen simultaneously, but where do they take place? This other one happens on an anode, the other one happens where? On the cathode. All right. So let's take a quick look at the questions that are possible that you can be asked. Okay. Having looked at the things that we looked at, the new information incorporated by the information we've learned in grade 10. What is it that we should know? Okay. This is taken from the previous question papers. It says distinguish between cation and anion. As we are in the exam season, please, the terms distinguish should be the basis of what you read, because now it tells you what to do. What is it that the question wants? If the question says explain, you explain. You distinguish, you distinguish. All right. So let's just familiarize ourselves with such terms so that we do what is requested of us. In this case, we need to then show the difference between the cation and an anion. And believe me, we did speak about it. Okay, we said both of them are ions, but how is then cation different from an anion? Because they are both ions, okay? So that one, we can just say a cation is positively charged ion, whereas an anion is a negatively charged ion, okay? And remember, we said that these are formed, the positively charged, the cation is formed by the loss of electrons, okay? So as the metals lose the electron, they become positively charged, okay? Then they become what? Cations, okay? The non-metals, okay, as they gain the electrons that are being lost or being lost by the what? The metals, then they become negatively charged because they have more now. They have electrons that are in excess. They have a lot of the electrons, okay? And because they are negatively charged, this a lot of things is negatively charged, then it's going to be negative. The whole ion is going to be negatively charged. Second question, it's your 8.2. Determine the oxidation number of each of the following underlying elements. Okay, write down every step, which will show how you arrived at your answer. So let's look at 8.2.1. So it's say K2S, all right? So we have to determine the oxidation number, okay, to each of the following that is underlined, Okay, so there's an element in this compound, there's an element in which they have not given us the oxidation number, but we have to find out the oxidation number of the underlined element. Okay, so and also we need to write down every step to show how we got there. How did we find that answer? Okay, so the first thing, you look at this compound K2S. Okay, so you're like, okay, because it is a molecule or rather a compound, so its oxidation number is going to be 0 because it doesn't have a charge. It's not an ion. Okay, so it's just neutral because that is the rule. All right. So that is why we're going to then write it in simple terms. Why are we saying 2K here? Because there is 2 atoms of what? Of potassium. Okay? And then we are done with potassium. And then we've got sulfur, S. And then it's got what oxidation, or rather, what is the oxidation number for the what? For the sulfur. We look at where sulfur is at. Let's go back a little bit. Sulfur, there is our sulfur in our periodic table. Okay, I'm going to circle it so that you are able to see it. So it has, because now of its position in the periodic table, okay, it's going to have a charge of -2. All right, so as we go back, that is why we have plus +2, sorry, plus -2, because of its position in the periodic table. It has an oxidation number of -2. Then we equate everything in here to what? To 0. The reason we are going to do that, we are doing that, is because it is a molecule, it is neutral, it does not have a charge. It's not an ion, okay? Because if it was an ion, that would have taken the charge of that ion. Okay, that is being rule number what? Let's just go back a little bit. That is being ruled what? Rule number 3. It says that in a molecule or a compound, the sum of oxidation number for each element in a molecule or compound will be what? Will be 0. For example, they gave us what? Water, okay? Because water is also what? Neutral. It's just a compound, all right? Going right back. So now we do our math to say 2K is equals to what? A +2. What we did is to transpose. So because now as we're transposing, this -2 is going to change its sign to be what? To be +2. We divide by 2 on both sides, and voila, we've got an oxidation number for K, okay, which is +1. Can you see the importance of the rules that we went step by step to explain? As you implement those, you start to understand it better, okay? Let's look at the other one, 8.2.2. We're still doing the one and the same thing. We are going to be finding out the oxidation number of manganese in this case. So because it is the one that is highlighted or underlined, what is it that we should do? Okay, so this is a molecule compound. Rule number 3 should apply in what? In equating it to 0. Okay, but however, we need to find the oxidation number for potassium first, and then for what? For oxygen. Okay, so we say for K is going to be what? 1. And why are we saying 1? Let me take you back a little bit. Let's go back to our periodic table. I'm going to circle potassium, which is what we are speaking about right now. Here's our potassium, okay, and it's in group number 1. Okay, because of its position on the periodic table, we have the general rule that we're going to give them what? A charge of +1. All right, moving right along again. This is where we were. So that is where this +1 came from. Because this one, the manganese, is underlined, okay, it's what we are looking for. Okay, some other people go as far as putting X to make it an unknown. Okay, but to make it just obvious, just put it back so that your answer cannot just say X, because you know what you're looking for, the oxidation number of manganese. And then positive, and then it's a plus. You've got 4 atoms of oxygen, okay? So that is why we have this 4, okay? Where is oxygen at in the periodic table? Can I take you right back? Let's look at it so that you best be able to see it clearly. Let's look at oxygen. Can you see where oxygen is at? There is oxygen, all right? And then it has a charge of what? Of -2, okay? So that is why when we substitute in here, we said there is 4 of the -2's. Yes, it is -2, but how many oxygens do we have? We've got 4. So that is why we're multiplying, because brackets means multiplication, multiplying by 4, okay, because there are 4 atoms of oxygen. And then we equate the whole thing to what? To 0. The rest could be maths, okay? What did we do? So we leave out 1 plus, and then 4 times -2 is going to be giving us -8, okay? And then it's still equating it to 0, okay? And then we then transpose, and then voila, we've got manganese having positive what? Positive 7, which is the oxidation number for manganese, okay? So follow the rules as they are. If you as you move on, you quite forget, go back to the rules, to the 10 rules that we have. See whether what you are given, the compound that you are given, where does it fit in? If you're not giving a compound, you're giving a monatomic ion or a polyatomic ion, go back and see what exactly did we say the rule for monatomic ion or polyatomic ion is, so that you are able to proceed nicely and get the correct answer. Okay, so that's how simple it is. So for your mesmerizing, here's the learner activity that I wish you could do for me. So it's the same thing as what we've been doing right now. It says determine the oxidation number of the element indicated in each of the chemical formula. Okay, so we did not underline it in this case. So we just said we want the oxidation number of Sb in Sb2O5, for P in Mg3PO4 all in 2, and then we've got S in NH4 all brackets 2 SO4, okay, Cr in Cr4 2 minus, and then Br in NaBO3, okay. So these are our underlined elements that we want the oxidation numbers for, okay. Hope you get this to be fun, okay. Do it nicely and then enjoy it. Enjoy it. It is just as nice, okay. Moving right along onto the next topic that we're going to be touching base today is electrolysis, okay. Now that we have the terms, the important terms, we can get into this one as well. So electrolysis is the process during which a substance is decomposed, broken down, okay. So to decompose something, it means that we are breaking it down into smaller substances, okay. But now when electric current is passed through it, okay, when the process in which a substance is being decomposed, when an electric current is passing through it. Now we've got certain terms that we have to take note of, which are part and parcel of the process of electrolysis. The first one, electrolysis takes place in what? In an electrolytic cell, okay, in which is a type of cell that uses electricity to drive a non-spontaneous reaction. And it is non-spontaneous because it needs the power supply. So it has the power supply for it to be able to move forward, okay? So meaning that without the power supply, this reaction cannot take place. So we kind of need this power supply so that the reaction itself is able to happen. Also, there can be a change in the energy conversion, all right? So we usually convert electrical energy into chemical energy with this specific electrolytic cell, okay. We're going to say an electrolytic cell is activated by applying electrical potential across the anode and cathode, which is basically what we've been saying, that it cannot happen simultaneously, spontaneously so, meaning it cannot happen on its own without the power supply, without the electrical supply. The reaction cannot happen on its own. So it kind of has to absorb this energy so that it's able to drive the reaction forward, okay? So it touched based also on two terms that we referred to, but I'm going to refresh your mind again. The anode as well as the cathode, it's still the same thing. The anode being the electrode where oxidation happens. The cathode being the electrode where reduction happens, okay? So this is just basically better explained like that. Remember the red cat and ox, okay? So that we're able to remember the mnemonics faster and be able to recall the important information, okay? Now, in an electrolytic cell, in which the electrolysis process will happen, so we have a liquid, okay, or rather a solution that conducts electricity, okay, through the movement of ions, okay? That we refer to as what? We refer to it as an electrolyte, okay? So I've got electrodes, which are solid. That is your anode, that is your cathode, okay? And then we've got the electrolyte, which is your solution that is able to conduct electricity through the movement of cations and anions, so we just say of ions, all right? So the electrodes are made of metal or carbon, okay? But we're looking for something that's not going to disturb our reaction as it moves forward, okay? And we then connect it to direct current, okay? One attaching it to the positive terminal and the other one to the positive and negative terminal. All right. So when connected to the direct current, one electrode becomes positively charged and the other one becomes what? Negatively charged. Okay. So this initiates then the movement, okay, of electrolytes towards the electrodes. All right. So positive ions will then move towards the negative electrode, and then the negative ions then move towards the what? The positive electrode. But you're going to do it diagrammatically so that you are able to see these cations, these anions as well, and how they are able to move to different electrodes. Okay, I always say opposite attract. Okay, why is that? Because the positive ions will move towards the negative electrode. All right, that is very important to note. All right. And then the negative ions will move towards the what? The positive electrode. Let's take a look at it. Now, when electricity flows through an electrolyte, the ions undergo a chemical reaction, hence the decomposition. Okay, so the electrolyte solution consists now and then of metal cations and then the spectator ions. The whole process of this salt being broken down into ions, your cations and your anions, is what we call electrolysis, okay, which take place in an electrolytic cell. All right. So then we can say the electrolytic cell is a device in which the electrolysis takes place. See how we play around with these terms? Right. Why do we have to do electrolysis in the first place? Because we want to do electroplating. Electroplating, where we're making metals to be more shiny and appeasing to human eye, okay? We're increasing its durability, okay? We're going to talk about it. We want to do electrolysis for purification of metals, okay? We also want to do it for preparation of chemicals as well as galvanizing. This is the benefit of just or application, industrial applications of what? Of electrolysis and technology. Let's look at let's look at it nicely, analyze it, so that the electrolysis process, you are able to speak it to another person and able to explain it better to another person. In this case, we are speaking or like looking at right now the decomposition of copper chloride solution. So what happens here? We're going to then first analyze the components that are here in the electrolytic cell. So this is a power supply. Remember we said that the reaction is non-spontaneous, meaning that it needs some kick. It needs the power supply. It needs some energy for it to be able to move forward or to happen, all right? So this is our power supply. All right. And then we've got two electrodes, Remember we said they're solid, they can be either, we can use carbon, okay, as electrode. So this is our cathode. What do we remember about the word cathode, the name cathode? It is where reduction takes place. It's another term. So what do you know about reduction right now? Well, you know that it is what? The gain of electrons. Can you see how intertwined the whole thing is? And then you look at the other one, the anode now. Then what do you remember about an anode? What do you remember from what we spoke about? What do you remember about an anode? An anode, it is an electrode where oxidation takes place. What is oxidation, you ask yourself? It is the loss of electron. Right? And then you look now inside the beaker. What is inside the beaker? Initially, there was copper chloride. All right? This is the salt that was just in water. We then began to stir, and allowed electric current to pass through it so that this copper chloride is able to break down into ions. So now we're going to have copper being a cation and then chlorine as being an ion. All right? So they're going to exist as, I'm just going to rewrite it across the beaker. So you're going to have like now your Cu2+, your Cu2+ wandering around. And then you're going to have your chlorine ions. They're going to be N ions. So you're going to have your Cl minus, your Cl, where can I write another Cl minus? All right. So this because now they've broken down to ions. So there's a movement of ions inside this beaker. Right. So what is it that will happen? And what is it that told us, for example, you were not told which one is a cathode, which one is an anode. You're just given this. Assume these were not given to you. The anode, cathode were not given to you. How could you then tell which one is an anode and which one is a cathode? You look at the terminals that are being connected on each electrode. So in a power supply, you're going to have a positive. The longer stick is your positive, and then your shorter stick is your what? Your negative. This is your positive, and this is your negative, and so on, depending on how many cells are being connected. All right. So in this case, they just connected 3 cells. A negative. All right. Now, in an external supply, so the movement of electrons externally always move from the positive to the what? To the negative. And I'm saying the positive because here is the long stick this side, and here is the short stick this side. And I know from grade 10 that this long stick is for the positive, negative, positive, negative, positive, and negative. This means that the movement of electrons in the external supply is going to be what? Moving in that manner. Because now that cannot then gain without losing, okay? So that means that there is going to be a loss. There is going to be a giveaway on the positive, because they're going to start moving, the electrons are going to start moving in an external circuit like that, and then they're going to the negative terminal, all right? So that means that on this side, we are gaining. On this side, there's a loss. What does that tell me? It tells me because there's a loss here, oxidation is happening on this side, and then gaining is happening on that side. That being reduction, and that being oxidation. Okay, so that how easily you establish it. But then what will happen to the ions inside the beaker? What will happen to the ions in the electrolyte? Okay, so you'll find that the N ions, and in this case, here's my N ion, will be attracted towards the what? The positive terminal. All right, so you're going to have your chlorine attached on this electrode. And because sorry, chlorine exists in a form of gas. What you'll see is that there's going to be a formation of bubbles all around the electrode. Okay, so here's your bubbles, which is what you're going to observe if we were to do the practical experiment of this decomposition of copper chloride. All right, and then why is that? Because now the chlorine ions are negatively charged. Okay, so they're getting attracted to the opposite terminal, which is what? The one that is positively charged. So that is what we meant by saying opposites attracts. Okay, and on the cathode side, now the what? The positive what? Copper ions. Okay, cat ions, Cu2 plus, are getting attracted onto this one. So here's your copper 2 plus, copper 2 plus, and they exist as for you to be able to see, oh, copper has been attached onto this electrode. Okay, how are you going to see? It's going to form a reddish brown deposit. Then you're going to say, oh, here's my copper. Because it is a deposit, it's going to exist in this form. And why is copper being attracted onto this one? Because it is positively charged. It is a cation. So that is why it is attracted to the electrode that is connected onto the negative terminal of the power supply. Okay? See how easy it is. So this then becomes the decomposition of what? Of copper chloride solution. Okay, so now we have to tell, how can then write what happened as a reaction that happened into an anode, and then what happened to the cathode electrode. Then we have to write it in an equation to show the gain, okay, and the loss of electrons, which happened simultaneously. So, okay. So let's go through what we'll observe. Initial color of the solution, which is a copper chloride, will be what remains blue, okay? And then over time, it remains changed, okay? It then appears that copper has been deposited to one of the electrode, but dissolved from the other, okay? That is why we're able to then see the decomposition, and we see the smudge of the reddish brown deposit. Okay, so we said that at the negative cathode, positively charged copper ions are attracted to the negatively charged electrode, okay, because opposites attract. The ions then gain electrons and are reduced to form what? Copper metal, which is then deposited in the electrode and then takes, which is a half reaction. So you've got a half reaction taking on the side and then half reaction. What happened? Let's write it chemically. So what is the reaction that happened? So you had copper, and it gained 2 electrons to become copper solid, because now you find that there was a smudge of it on the electrode itself. And then moving right along, what is it that happened at the positive anode? So there was a greenish bubbles that you observe. Remember, because of the nature of chlorine existing as a gas, okay? So how do we then write the reaction that takes place at the anode? So we had chlorine, then it lost what? It has lost 2 electrons, then it became what? 2Cl minus oxidation. That happened, all right? So we usually do electrolysis when we are electroplating, okay? Electroplating is the process of using electrode deposition to coat an object in a layer or with a layer of a metal. All right. So we'll have a metal, and we're trying to coat, whether you want to coat your spoon, your necklace, your earrings, anything that you want to coat with a certain metal. For example, we can have metal like gold, and you want to plate your earrings to be what? To be gold. So what you'll do is that on the cathode side, let me go back a little bit. On this side, this is where we put our objects that you want to coat. okay? Your earrings, your necklace, your watch, your spoon. What is that item that you desperately want to coat? And then on the anode side, this is where you put the metal that you want to coat this object with. Okay, so in this side, you want to put that specific metal. It can be your gold, could be your silver, it could be anything that you want to coat it with. It could be anything, any metal that you want to coat the other object to be. Okay, so why do we do this? It can't be vice versa, because electrons need to move. We have to take the deposits from this metal and place it onto the what? Onto the object that you want to coat. That is why we call it electroplating. We are plating the outer part. We're trying to enhance how it appears. We want to make it shiny. Hence, we'll put a metal on the side because metals are shiny. Okay, we want to increase durability. Okay, we want it to last longer. Okay, so we'll do it for all those reasons. Okay, so now engineers use controlled electrolysis to transfer the desired metal coating from an anode to a cathode. Okay, so that is why it is very important that you know, or you understand why on the anode side, that is where the metal will be used. The metal is placed that is supposed to coat that particular object. Okay, and then on the cathode side, the object that is supposed to be coated by this metal is then put there. All right. So electroplating improves the appearance and the functionality of many appliances and components around the kitchen. For instance, we can talk in terms of the utensils, the cutlery, the pans, the taps, the kettles, and so on. So all these benefit from electroplating as it improves their looks and makes them easier to clean. All right. So this is basically how electroplating will be conducted, okay? And we are saying this is an anode. And basically we're saying an anode because it is connected to the positive terminal of the battery, okay? And this one being the cathode. Remember how the electrons move? They always move from the anode to the cathode, because the anode is where your oxidation will happen, the loss of electrons being taken from the metal and then into the what? Into the item or the object that you wish to be plated, okay? In this case, there is silver. That is why we're going to put silver nitrate as our electrolyte so that it breaks down and then into what? Into ions, allowing then the metal deposits to move from the metal itself into the spoon. In this case, we want to plate a spoon. We want to make it silver, okay? Now, let's look at the questions that are possible so that we can see whether we did understand the process of electrolysis. Okay, taken from a previous question paper, I just took the part that's going to help us understand better the concept of electrolysis. All right, so 8.4 said, the experimental setup shown below was used by the educator to demonstrate the electrolysis of copper chloride solution. Okay, so we've got copper chloride solution as our electrolyte. All right, and then we've got electrode A. They don't tell us which one is which. And then we've got electrode B. All right, so and then we've got the power supply. The mere fact that there is a power supply means that this is what? An electrolytic cell. It is a non-spontaneous. We need this power supply for this reaction to take place, all right, because it can't happen on its own, right? Let's look at the questions that follow. Oh no, oh no, right. Okay, first one is saying 8.4.1, the term, define the term electrolysis. We did define it. I know you know it. Okay, let's define it together. It is a chemical decomposition produced by passing an electric current through a liquid or a solution containing ions. So you want that electric current to pass through so that decomposition can happen, okay? So that there is movement of what? Of ions, all right, for 2 marks. Please learn those definitions, write them correctly, because with definitions, as you go to the exam season, it's 2 marks or nothing. You write them wrong, you write them right, then it's 2 marks, all the marks. All right. So please train yourself to write correct terms. All right. 8.4.2. Why are carbon electrodes preferred in this experiment? Why would we prefer carbon electrodes specifically on this one? It's because they are non-reactive. They will not jeopardize our reaction. They will not get involved in our reaction. We don't want it, but we want just the electrodes that will be inert, okay, that will be non-reactive on the experiment. They will not find it reacting with the what? With the salt solution, okay, jeopardizing the whole experiment. All right. 8.4.3. What experimental observations will be made at electrode A and B? Okay, so this one requires us to identify which one is an anode and which one is a cathode. Okay, let's take it back. Let's talk it through it again. We said that the positive terminal, and then this one is the negative terminal. And we said that the movement of electrons in the external circuit always move from the positive terminal to the negative terminal. So there's a loss of electrons, there's a gain of electrons. What does that mean? That means that over here, there's got what? An ox. Okay, so on this side, electrode B, this is what? An anode. What happens in an anode? Oxidation. What is oxidation? Loss of electrons. Right. They're being lost, they're being gained. Okay, what happens here? This is our cathode. Let me write it nicely. And this over here is our cathode. What happens in the cathode? Reduction. What is reduction? Gain. See how easy it is? Now, because now we can tell this one is an anode and this one is a cathode, then we can tell where these are going to just be attracted to. So as the Cu2 plus breaks down and the Cl minus opposite attracts, all right? So that means that the copper is going to be attracted on the side. Why? Because it is a cation, so it's going to be attracted onto the negative terminal. And then over here, there's going to be Cl minus. Why? Because it is attracted to the positive terminal. All right. So remember, chlorine exists in a form of gas. And then, so that means that here we're going to see bubbles, the greenish bubbles. And then over here, we're going to see a reddish brown deposit. Okay. So when the question then says, what experimental observations, what is it that you will see? All right. So electrode A, what you will see a reddish deposit. And then electrode B, so that is why we said copper or we deposited on the electrode, so the reddish brown on electrode A. All right. And then on electrode B, bubbles will be formed around the electrode. They are our bubbles over there. Okay. Moving right along to question 8.5. Which one electrode is the anode? Which one is our anode? Okay. We already answered that. Let's take a step back. Which one is our anode? Electrode B is our anode. Okay. It is our anode because oxidation happens there. What is oxidation? Is the loss of electrons. Okay. So that is why we said in the anode it's B, okay, with the electrode in which is a cathode is then going to be what? To be A. All right. So they say that for this electrolytic cell in operation, okay, what the question is saying, 8.6.1, write down the half reaction that will take place at electrode A. Now we know, okay, that we're going to have copper attaching onto electrode A. But what will be the half reaction for copper? All right. So copper was missing 2 electrons, and then it gained the 2 electrons, and then now it is a happy copper. Okay. And then half reaction for that will take place at electrode B, knowing that is the anode. Okay. Anode having to lose, okay, electron. Okay. Chlorine was like this. It was Cl, 2Cl minus, and then what happened is it has lost this electron. Okay, it has lost what? 2 electrons. Okay, so it becomes a sad chlorine. Okay, because when you lose something, you're sad. Okay. Now, I want you guys to attempt this one. Okay, learn activity number 2. 8.4, it's going to give you a better understanding. So as you do it, then you're going to understand all the terms that we spoke about nicely and all the content nicely. All right. So 8.4, the experimental setup below was used by learners of technical sciences to investigate the electrolysis of copper chloride solution. Still, they're talking about the copper chloride that we spoke about and did activities with, right? Now, the first term, but even before you look at the questions, please analyze what is given to you. Read the statement that is given to you. Number 2, look at the diagram that is given to you so that you are able to then have a strategy on how, okay, you're going to answer the questions. If it means analyze as far as labeling, okay, and which one is which, please, by all means. So in this case, we're given the battery. They just showed a battery. All right. So you've got the 2 electrode as pair you will see in your electrolytic cell, and then you've got your copper chloride. All right. So they say define the term electrolyte. We did speak of in terms of an electrolyte. What is an electrolyte? Why is the carbon preferred? Okay. They say, why is the carbon preferred as an electrode? Okay, what does it do that the other electrons don't do, which is an advantage? Okay, 8.4.3, what observations will be made at the electrode P and Q? What is it that you will see? All right, 8.4.4, which one, electrode P or Q, is the anode? Which one and which one is the P or Q is the cathode? So just identifying which electrode is which. Write down half reaction that will take place at the cathode. Okay, show how it will gain or how it will lose the electrons. Okay, 8.4.6, write down the half reaction that's taking place at the anode. And then lastly, what are the uses of electrolysis in technology? Remember all the 4 that we spoke about? Yes, those are the ones that are needed. All right. So we're ending today's lesson, which was very good, by a quote from Abraham Lincoln. The best way to predict your future is to create it. We're going to not stare at the walls and start creating the things while we are not doing anything. We're going to stand up and create our future because our future lies on our hands. I hope you had fun because I did. Okay, see you next time. Have fantastic time with your exam. Please be prepared. Be overly prepared. Go through your content, go through your notes, go through your past question papers, just as create your future. Okay, let's not predict it, let's just create it. And how best can we create it is to just make sure that we are overly prepared for anything, for any exam that we are about to write. Okay, on that note, I hope you have all the fun in the world as you're going to study for your exams. All right. Thank you very much for joining us on today's session. See you next time. Bye.